Alrighty, can everyone hear me? All right, we are good everywhere back there. Can everyone see me? The Discord people are all nodding, cool. I had them install some spyware into Discord so that I could see you all. Kidding, of course, obviously. Although some of you are going, well, I mean, maybe. It's a little bit of the state of our industry sometimes. Hey, I am so excited to be here, guys. Man, in February when we sent out the proposals for talks, I had no idea what this year was going to look like, and I am so excited to still be able to give this talk to you guys today. My name is Ben Potter, and today we are going to be talking about something that I've found to be really near and dear to my team and something that's really important to my company, and that is validation UX inside of our very large web application. And so this talk is entitled Unifying the Validation UX with Vue.js. I'm going to jump in real quick to tell you guys a little bit about who I am. I am a senior UX developer and full stack developer at a company called PAI. We're in Billings. I live and work there. And since COVID, we've been working from home since March, and I'm kind of loving the work from home life. You can check out the COVID do I've been rocking. A little bit about what PAI is and what we do. We are a company inside of the finance sector. We are a massive ecosystem dealing with ATMs. And that's a really interesting sector of FiTech because very few people actually think about what is going on with an ATM when you put your card in and cash comes out. It does not start and stop there. There is massive amounts of stuff happening behind the scenes to make that transaction actually happen on the ATM. We offer a highly tailored software suite to handle everything that is involved with running a single ATM all the way up to tens of thousands of ATMs under a single partner with our company. We have a very small team, generally speaking. There's about 15 people in the department. The company is about 200 to 300 people. We offer amazingly complex billing and reporting for all of the things that are involved in ATM space and that ecosystem. And ATMs have a huge amount of configurations. So we have a very, very deep and complicated form infrastructure inside of our application. Quick little rundown about our stack. We are a single point of entry web SaaS. That's mobile apps, desktop, web, etc. We are run on a Java backend, and we have about 130 to 150 microservices that handle vendor data, jobs, etc. We interface with lots and lots of different third-party companies to take in data, analyze it, and do things with it. Because of the space that we're in, almost all of our stuff is custom infrastructure because it's pretty much unique to us, and we are one of the key leaders in this particular sector of FiTech. We are actually a fairly old application. I think we're about 18 to 20 years old, somewhere in there. And we have many, many generations of frameworks spanning the entire stack. We have something like 5 different data interface structures, from Japa to Homebrew's version XYZ across that. And every gambit of different varieties of JavaScript inside of our front end, all the way from jQuery's native JavaScript all the way to now Vue, and even most recently we've started introducing TypeScript inside of our web application. We're in an interesting domain, and we have interesting problems inside of that domain, and we're doing really neat things right now. We're even dealing with like Bitcoin on an ATM. We're going to be able to buy and sell Bitcoin from any ATM in the country. We do dispatching for cash loads. We do forecasting and analysis on whether or not an ATM needs to have money put in it and when that can happen, how we can dispatch that job off to various groups of third parties that we interface with. Couple caveats about my talk. Like Rob said, there are slides in the Discord. I would highly recommend you guys get into that because I have a lot of dense code that I'd like to show you guys. Because some of this is pretty cool, and we're gonna just deep dive into some of the actual code that I've written to actually accomplish some of our solutions inside of our domain. But domains shape decisions, and so it's important to remember that what I'm doing here is because of the domain that I'm in and because of the type of work that we're dealing with. It's also important to know that what we're going to talk about is not exclusive to Vue. You can do this in any front-end component framework that has some sort of store. So Vues is Vuex, and then you've got Redux for React and NGRX for Angular, et cetera, et cetera. What we're going to be looking at is not a library that you can just grab, drop into your project, and have it just work. It's not far off, but that's not what we're here to look at. There are also amazing frameworks out there for dealing with validation, but why don't we expand their potential and make them more powerful? Some of the examples that we're going to be looking at are examples, and it's important to remember examples are examples. And we're going to be talking about UX and not UI. We're not going to get into the minutia of where you should put particular things, how that should look, what colors you should pick, although that is incredibly important to the actual UX involved in what we're talking about. This talk is focused on getting that experience that the user encounters when they're dealing with forms on your website to be consistent. And like all things inside of tech, your mileage may vary. This may be super relevant to what you're doing, and it may be a complete miss for what you're doing. All right, why this topic? Let's dive into this. So forms are something just foundational to web. They are on every website on the web. And every website does forms a little bit differently than every other website on the web. Their validation UX is a little different, the way that they look is different, et cetera. And the thing that is crazy to me is when you look at websites, every website seems to do this differently than itself. And I think that's because, you end up with Dev A over here working in this space, implementing validation UX over here this way, and Dev B implementing it this way. And they drift apart, and they're just not consistent. And why do we end up with web that looks kind of like this, where we just have such a hodgepodge of different ways of dealing with this? When I was thinking about this talk, one of the first things that jumped into my mind was Facebook. Early on, their sign-up form behaved radically different than any of their settings forms did. When I Googled some just examples of validation UX, these are some things that pulled up, and there's just a gambit of crazy inside of here. There's some good in here. There's some just awesome. I love the one underneath the Facebook one where it says there are validation errors and it blocks you from touching the form. Fantastic UX. And the other ones, they have maybe some UI things that are fighting with their UX inside of the validation. And it's just kind of a mess. It's also not particularly uncommon to run into sites where they'll bundle all of the errors up to the top of the form and just expect you to be able to find a particular field inside of the form that has the error that you need to go fix. And so why is this the way that this kind of is? And I think that this basically boils down to is this stuff suffers across the web because this is actually a fairly hard thing to implement. Loads of devs inside of loads of teams across the country hold the full stack title, and that to me generally just means master of, or jack of all trades, master of none. And validation UX is literally going to touch every single piece of your stack. It is your HTML, it is your CSS, it is your JavaScript, it is your server. It is that entire cycle, and it is a round and around type of situation where each of those little layers is affecting each of the other layers. And a lot of places just don't have strict style guides to make this consistent across their site. They also often don't have strict behavioral guides across their site to make this consistent. And all forms on the internet are nowhere near the same. A sign-up form for a newsletter is a radically different thing than configuring an ATM. Configuring an ATM is hundreds of data points spanning many, many pages. They're very complex. And additionally to all of this, design changes over time. I've been with PAI for 6 years, and in that 6 years, we've dramatically change the way that things look, and that ends up impacting that UX for validation. And where do the messages go? Do they go up here? Do they go beside the thing? Do they go under the thing? What do we do? And that stuff drifts apart because when you work in a large legacy system, it's impossible to get all of that stuff buttoned up all the same at once, especially while you are moving new development at the same time. And so those are general problems. And we have special problems inside of our space because we're in FiTech. We absolutely have to be server authoritative. Every single form that enters our application has to be validated on the server because we're talking about moving millions of dollars over the span of a year. And if that's off by a little bit, I mean, it's huge ramifications. We also have absolutely massive pages because some of the things that our systems deal with are just large and complicated. We also have lots of interconnected data points. An example we'll look at in a little bit is a terminal cassette. It's the actual physical device that goes into the vault of an ATM that actually dispenses the cash through the dispenser. You wouldn't even think about that being complicated because it's literally a bread box about this big that you put money in and then it comes out of it. But as far as configuring that is concerned, it's monumentally complicated because there are things like insurance at the bank and how much money a loader can have in a bag at a particular time and how much we need to put in a particular thing and how much can a whole ATM have in it across 4 different cassettes. And validating each of those fields that affects all of those things is really tricky. And because we're a big legacy application, we have a diverse and aged set of ways of interacting with the server back and forth. We have at least 3 different major frameworks for interacting with the server, and each of them are different and unique in their own little ways. So let's jump into a little bit of the how this can be solved, or how at least I've solved it, okay? In general, web forms and the validation tends to look like this. We end up with form controls in the HTML. They get piped up to the server one way or another, either through the native posts of a form or through some JavaScript. Doesn't really matter how they make it up to the server. And the server does some work, and it sends it back down, and that JavaScript intercepts that data, and then it affects the form controls on the page. Now, in general, we have a little bit of data on the page, and we have a lot of bit of data coming down from the server. We basically have a control name inside of the page, and then coming down from the server, we're going to need general messages for errors. We're going to need particular fields that have errors. Maybe we need a particular error message on a particular field. Maybe we need a single message on multiple fields. It's a large set of potential issues, okay? And the JavaScript is then responsible for pulling that all apart and stitching it back into the form in some way or another. And that right there, the JavaScript back to the form, is where I have seen our stuff historically fall apart. It decays right there the most often because our DOM drifts differently than our JavaScript. It shouldn't be that way, but it's actually just a reality of our industry that things drift at different rates. And so a simple DOM change or a simple CSS change can have massive ramifications to the validation UX, as something as simple as an alignment issue in the CSS changes. And I think that that is largely because the JavaScript is so responsible for understanding how to push that information into the form. And so I was thinking about this, and we've introduced Vue about 2 years ago now at this point, and I'm thinking about how we solve this, and I'm like, oh, hold on. This is maybe just backwards right here. What if the JavaScript never talked to the page again after we got a validation message back? What if instead it took those errors from the server and it put them somewhere? And it just set them there and left them there and forgot about them. And then the page could know that that thing was in that place and reach into it and interrogate that object continuously with the reactivity model inside of web component for state change. So the second an error pops into there, if I care about that error, oh, well, let me just render my error. Vice versa, we can clear those errors very quickly, and they can affect other components on the page because we're all just looking into this single point that all our JavaScript is doing is just writing things to. Let's dive into the actual implementation of that strategy. It's very straightforward. The Vuex, if you're not particularly familiar with Vue or Vuex, the Vuex piece of this is incredibly simple. I'm going to register a plugin, install function Vue and the store. That's the first piece there. We're going to register a new substore, and I'm just going to call it errors. It's not complicated state. All that we need to store inside of here is very simple key value pairs. And so we can just have an object called errors inside of our state that we're going to push things to. We have two very simple mutations, the first being a set error. That's just going to add a new reactive prop to that errors inside of our state at the key with the particular value that you've passed in. Nothing interesting there at all. Clear is just going to take that state and just empty errors entirely. We have one accessor out of here that is just going to reach into errors and pull a key out, and it'll have a string on the other end. Nothing interesting there. Next, we're going to take this and we're going to expose the store to our application in some easy to access way. I've added a $errors thing to the Vue prototype across our application inside of this same plugin. And it's very simple. We're going to have a way to set an error. We're going to have a way to clear an error. We're going to have a way to get an error. We're going to have a way to clear the entire store. And then we have two sort of advanced features towards the bottom there. We have the has errors and FindObservers. And I will show you some incredibly cool things we can do with those here in a minute. Using these things is very simple, obviously. We've got some examples there over on the right of what these actually look like. Nothing interesting, honestly. They're just simple JavaScript executions. Outside of that, what we need to do inside of Vue is we need to globally register some variety of a way for all of our components to reach into that single point and access the errors. Easiest way to do that that I found was to build a mixin and globally register it. So every single component across our entire stack has the ability to have an error on it. You'll see over on the left that basically we've done that by exposing a single prop called observe error. We've set its type to a string or an array. And that's really important when we get into some of the more interesting examples here in a second, that array part is. We have then one computed. You'll see that over on the right at the top there. And that is just an error state computed. Basically what we do is we say, hey, if I have an observe error, if it's been specified on the component that I am, I'm going to evaluate whether or not it's a string or an array. Nothing particularly interesting about that. And then I'm going to reach into that store and do things. You can see there, if it's a string, we're just going to go grab that one key and pull it out. If we've been handed an array for the observers, we're going to rip through that array and pull out all of the errors that are relevant and join them all together. Down below, we have a very simple way of clearing a particular error. It's the same type of thing. Basically, it's in reverse. We're just going to reach into there and set basically an empty value on that particular key because we've already established the reactive key in the store. We may as well just leave that key there. The one thing to note, we just looked at $errors and the slide before this, and inside of here we're not actually utilizing that. The reason that I'm not actually using that directly in here is that these last three slides are all inside of the same singular plugin. And so I already closed over the store and have it available in my scope, so I can just talk to it directly without having to reach into that prototype and pull back out. Moving on, like I said earlier, inside of our stack, we have, so basically what we've looked at so far is just everything we need to set up to make the store read and write information to a particular place and be able to represent that on a particular component. What we needed then after that was some way to normalize our interactions with our diverse set of ways of interacting with our server. Up on the left, what I ended up creating is something that I called response wrapper. Basically, what this function is and does is a lightweight shell around Axios that can just dispatch a query off to Axios with all of the features of Axios, and then I can intercept that response from the server, analyze it, figure out which of the sets of error responses that we can expect from a server, and normalize it into that store. And so the top example here on the left is basically the signature of what response wrapper ends up looking like. And down below that is a bit of the guts. There's some stuff above and below it. It's not important to what we're talking about. And what that is doing, it is analyzing that response and dispatching that response over into error util to actually write it to the store. Something that's really important to note here is that one of the key arguments inside of response wrapper is Vue. Because we need to know which instance of Vue we need to actually put this stuff onto. We see that over in the example bottom right. So you can see Vue there, tucked in there in the actual execution of wrapper. And error util up in the right is really straightforward when you actually get right down to it, because all it's going to do is unpack whatever variety of error response we've received from the server, and it's going to unpack it and normalize all those keys that have slight variations across our different ecosystems into the $errors. And so you can actually see, so handle from wizard, object.keys errors for each key, view $errors, there's that prototype, set error, key, errors key join, and we push them all together based on what that object is looking like. And then we have the other one, which is coming from a validation exception. And we can see that it's got a thing called a field name with a validation exception. And the subtle difference there is that like those exceptions are all bundled together in the server as opposed to the other one. And then we can see, like I said, there's just a very simple example of what this ends up actually looking like while we're using it. It's basically just Axios, and then we add Vue to it, and it turns on all of the validation behaviors. Now, let's actually just look at using this, because it's actually really, really simple when we get right down to it. Top left example right there is some of the guts of what one of our controls across our stack actually ends up look like internally. The key piece there is vif error state, put an error container into the page with error state in it. And if we remember back to what that computed was, that's going to end up being a string of whatever the key on whatever the components observe actually is. Below that, we can do slightly interesting things, like I have a message box component, and so it can either observe an error state or have a message set onto it directly. And so we can just pick one of those two states. And then inside of one of like my input controls, when value changes, I can say, oh, if I have an error state, let's clear that because I changed, which is something that gave us a lot of problems over time. That's been a particularly hard thing for us to deal with inside of our largely complicated forms is when this value changes, what do I need to clear? I have absolutely no idea what other fields I need to clear, and I need to come up with some strategy to actually describe that to the JavaScript dealing with manipulating the DOM in a way that it actually makes sense. Because if you just leave part of the form in an error state and highlight a particular field after they've edited a field that is connected to that other field and it stays in an error state, then you get phone calls. And you get people that are confused by the way that that's working, because that's a bad user experience. It should have cleared, and that was something that we needed to solve. And so if I observe a particular key and something else also observes that particular key, and one of those fields changes, well, I'll just clear them both. That seems easy enough to me. When we go up to the server again, if the validation passes, we're good. If not, we'll get that same message back, and they might need to reevaluate the other field, figure that out. And we can ask a particular thing to observe any number of different things, which we'll look at in just a second. Actually using this is actually just insanely simple when it gets right down to it. You can see in the middle there at the top, we have one of our PAI inputs. It's bound on a particular model, nothing interesting there. And the key piece to actually turn this entire thing on is observe error equal low limit. That's it. That's all they have to do to get that field to highlight with a message in any page of the application. Our UI looks something like the things in the corner. So there's a very simple example of an input, a radio button, something that we call business control. That is one of our key objects inside of our system. And then an example of what the UI looks like when you hover or click on the field. You get that entire error message. Now, this next piece is where this starts to get insanely cool for what we're dealing with inside of our complexity. So remember I talked a little bit about cassettes. So on the screen, I have an example of what some of the actual UI for a cassette inside of our application looks like. And so, like I said, it's a little bread box. You put money into it. It goes into the vault of the ATM. The big feeder machine at the front of the vault will pull cash out of that and hand it out of the actual dispenser in the ATM. And so we need to know things about that particular cassette, like how many bills can it actually hold? What is its actual physical dimension? What denomination of bills do they actually intend to put in this cassette? What is the maximum number of bills that they're allowed to put into that cassette? It may be different than the capacity. In this case, it's errored because it's over the capacity. I've set this particular cassette to have a capacity of 800 bills, and then informed it that I'd like it to have 1,000 maximum bills inside of there, which is now an issue. Now, what you'll see is that all of those fields are angry. And the reason that all of those fields are angry is that all of them have the capacity to affect all of them and reset all of them and fix all of them. If I bump the capacity in this case up to 1,200, we're good. If I set the denomination down to 10, we would still not be good, but we may, just depending on how the user is dealing with the maximum load, they may be calculating that and having that calculate what the actual max bills is, and they may have just mistyped that number. And so any of those values changing has a potential to correct any of those other fields. And so what we can see in the middle from that example is the actual DOM, the actual Vue components that are actually running all of that validation, making all of that work. And you'll remember when we were looking at the mix-in that I said the array was important, and we can actually see why that's important right here. And so on that first select there in the middle, fourth property down, we have observe error equals array, ci underscore max load, and c1 underscore denomination. That is a particular decision, the one, that's for a particular state of the validation that we can generate. On the next one down, we can see on the third prop there, we are looking at ci underscore max load and max load. On the third one down, we can see the same thing. We're looking at ci max load and max load. Because I also forgot to mention that we can have between 1 and 8 cassettes on a particular device, and knowing which of those cassettes has the error on it is actually really, really important, because we have an array of data going up to the server, and now we need to send that response down with some indicator of where inside of that set that actual error exists. And so we've built out incredibly awesome improvements to some of the validation strategies that we have in the Java code to actually help us understand where in our request, at what layer, ad nauseum, down any depth, a particular error is. So if we, at the top level, have an array of things that then has an array of things that has an array of things, we can actually build automatically for our developers error keys that say I'm this field at this index, at this index, at this index, and then they can just, they're obviously going to be matching that same structure inside of their DOM, because they're they're representing the request with some structure, and it ends up lining up most of the time. And so they already have the loops. They just add the extra keys to their observers, and they are off. Because that's something super relevant to what we're doing as large sets of form elements that you can dynamically add and remove things from. So, like, that's it, guys. Like, that's how simple we've boiled it down to make it just work for my entire team. They literally have gone, we've literally gone from validation UX being one of those things that you got to, like, at the end of developing a new feature and you were like, oh, I have some extra hours, we'll tack it on or we'll build it. Dealing with it in jQuery land a few years ago, to literally, okay, well, we'll just add the validation annotations that we need to the various places up in the server. We'll put the appropriate keys on the fields while I'm typing out what the actual field names are, because they're gonna match most of the time the way we have some of that stuff structured now. And it just happens and it just works. And our users gain a huge amount of benefit from that because it's just the same on every input, because they're a little Vue component. They're gonna look the same always, everywhere across the site. And that UX is so easy to implement that it may as well be implemented everywhere on every field that has validation. Now, I mentioned earlier that we have some advanced features inside of here. The key ones, we'll just jump back to has errors really quickly. So has errors basically is really simple. It takes an array of keys. It just walks through those particular keys and looks for errors on any of those keys and just says whether or not it found any errors on any of those keys. And so what we can do from here is let's take a look at the guts of what FindObservers can do. Basically, it is a function that, given a Vue element, or a Vue node of some sort, it can walk that entire node tree and pull out every observe error prop on every component all the way down that entire tree. It's going to take all those, it's going to pull them up and collect them and hand them back out to me as an array of here's everything that rendered and here's everything they all care about. What we can then do is we can, on like a mount of a particular component, we can ask that the $errors FindObservers to walk our tree and hand us back those observers. We could make a little computed that takes all of those observers that we found inside of our thing and analyzes all of them continuously for any particular error coming on. And then we can do some interesting things with that, like the two forms that we can see over there. One of the spaces inside of our application that we needed to deal with recently was this place where customers can add fees to an ATM. And the way that that UI works is you have a whole bunch of little rows of what the fees are with a little breakdown of what's in them, and then a way to pop open a way to edit them. What we needed was to know, when we took that bundle of information and sent it up to the server to validate, we needed to know if one of the particular fields in a particular row had a particular error and indicate to the user in some way that they are interested in a row for a particular reason. And so we can see on the top there, that's that little triangles, the bottom left HTML there. We're just saying, hey, if I have errors, put this triangle in here. And then when they open that form to actually look at that, because that form is just nested inside of that row, we have the start date and end date highlighting themselves with errors. And you can see a perfect example of where we have things that are often connected. Dates are an obvious example of interconnected data points. The error on there is that the end date must be after the start date, which could be cleared by changing either of those values reasonably, right? And so this tool, this observe error framework that we've got here has given us the ability to just very, very quickly, man, like it's so cool to be able to just like highlight an entire section red that has an error in it. I have a dream down the road. I haven't had the time to dig into what this looks like, but we're all very familiar with the way that our IDEs show us errors, where we have the ribbon along the side of the scroll bar. We don't think about that on web, but when you have a page that can scroll and scroll and has sections that open and close and load data asynchronously, and just they have a lot of stuff available inside of them, man, how cool would it be for our page to be able to dig through everything that's in there, find the things that have problems, figure out what elements those components actually are, figure out their space inside of the page, and actually put a little tick on the side of our scroll bar that indicates where that particular error is. Obviously, that is not applicable to everyone because huge forms are not what you should be aiming for, but they are a reality for some things. But man, just like, how cool would that be? So hopefully, we've gotten a little bit of an idea of why I think that this is something important, and hopefully we've seen a little bit of how we can try to solve this, or at least how I've tried to solve it. And we've had this system in place for a little more than a year now, and let me tell you, it is fantastic. It's so nice, in fact, that I've got a fully functional example up at this URL here that you guys can actually go click through and take a look at. We can pull it up very briefly just so you can get a sense of what that ends up looking like. It's just BSDC 2020-BP-demo. And it's just a code sandbox with a very simple form and a fully fleshed out version of that errors plugin that we were looking all the way through. And so what we can see is we have the form there. It's got some inputs in it. We can see that observe error prop here. We can see those particular things filling out here. What we can see is that the first one observes error 1, the second one observes error 2, and then the bottom one observes error 2 and 3. And so we can set error 1. All these buttons are doing is just setting this particular static error message at a particular key into the store, and then the component is analyzing that store and pulling that error out. And so then we can do really neat things with error 2, because example 2 and example 3 fields both care about that field. And so when we set error 2 into there, we end up with that error on both of those fields. And we can also set error 3, which just appends an additional message to that piece there. And then we can clear each of those fields by typing things. And so what we see there is example 2 lost its error message, which is great. And example 3 lost the error message that example 2 had, which is awesome. Like, that's so awesome. If we clear 3, we just clear it out. And we can then just talk to the entire store and ask it to clear all of those error messages. All right. Rob, I believe I am ready for some questions. Hopefully you guys were in Discord. It's been really cool watching people talk in Discord today.
All right. So my first question that I really want to know, how do you get the Bitcoins into the ATM cassette?
So that's actually a funny question, because legitimately we've been wondering the same thing about how we should deal with that, and we've come to the conclusion that we should build a new dispenser, that emits the Bitcoin, to the user after they've bought it, because that makes total sense to me.
All right, so how about around testing of your error setup, do you have any kind of automated testing for the component themselves or the store? And then do you also test the components that are using the error handler?
Yeah, so we do have automated testing. We're just using the, wow, you're putting me on the spot on the Jest test for Vue. Nothing particularly interesting about that. The reality of the tests for these components and this particular piece is that this particular piece is not tested explicitly. There is absolutely no reason it couldn't be tested. It's just literally the simplicity of some of this. I mean, we can actually see, this is, I'm not even kidding, basically what our PAI input looks like plus a bunch of style sheets. There's nothing interesting here.
So when using something like this on like a public facing interface, would you handle anything differently between how you have your setup for inline errors versus having a list of errors at the top of forms in order to kind of have balance your visual experience with your screen reader experience?
Yeah, so the super cool thing about the way that the store is working, if you wanted to make a key that completely described the field and take those keys and stick them with their error messages right up at the top of the screen for screen reader, it would be no different than asking it to dig through all of the errors inside of your page with that FindObservers thing that we were looking at and having them render out into a space for the screen reader. Yeah, absolutely, you could do that.
Nice.
It's a great idea, actually.
How about in your application, how many error observers do you have at once? And is there a limit, before it starts to get slow?
So the largest page that we currently have this thing on has offhand guess about 80 of them, and we have seen 0 issues running that many. Obviously, if the user is hitting the page in a way where they're generating all 80 errors, that's we've failed in some other ways. Like I said, we're server authoritative and we write a lot of our validation in the server. It doesn't mean we don't write validation inside of the client. But what ends up happening most of the time inside of that space is that our client validation is handling the really simple stuff like this field's required. And the server validation is handling the really complicated stuff that's really important, like this value is too big and is going to make your payout blow up.
Do you handle the messaging differently between errors that come from the client side versus errors that are returned from the server?
Yeah, we don't at all, because that's the beauty of having a shared space to put all that stuff. It's just keys and messages. And that is really where the power for this comes from, is that there is absolutely nothing stopping me. I mean, if we wanted to, if you've got the example pulled up on your screen at home, do this for me. Literally, just inside of the, make a created block in one of the components, or maybe the form on this example, because you can edit this, it'll make a copy of it for you. Just make a created block inside of there and say this $errors, let's set error 1, and give it a message. Absolutely. And this is why I say that there's amazing front-end validation frameworks out there for handling stuff, but we can make them better, because we can talk to a single spot to put that type of information any way we want to, and then pair that with like Vuex. We could build a plugin to push stuff into a store and make it work exactly the same.
All right, I think that's all the questions. Thank you very much.
All right. I'm in Discord. If you guys want to talk to me about anything afterwards, just hit me up, DMs, or just talk inside of the channel. Thank you so much, everyone, for listening.